Thanks very much for having me, Jessica, and everybody from Cockroach Labs and Mesosphere. This is fun. As you mentioned, I'm from Tierion. We're a San Francisco-based company, and we are building something we refer to as a global proof engine. This is a platform that we're building that allows you to give us a representation of any piece of data, and we will anchor that to public blockchains and provide you with a cryptographic proof. Okay. And wow, I sound different on this one. And it will provide you with a cryptographic proof that you can retain custody of that proves that a piece of data existed at a point in time in a certain state. So there's a lot of talk about blockchain these days, of course. There's some uses that it's appropriate for, and maybe some that it's not so appropriate for, and people maybe have misunderstandings about what the blockchain is at all. And it's definitely not mauve. Why can't we put everything on the blockchain? So this is a common question. You know, if we wanted to anchor data to a blockchain and prove that something existed, why not just put the data there? And the reason is because blockchains are incredibly sensitive to how much data they can store. So you can only put little bits of data, and so that's why our solution is based on putting what we call a Merkel root into a blockchain. So this was something that our CEO, Wayne, thought was something that the industry needed. And he and his co-founder, Jason Bukowski, came up with Tierion, and the company launched in 2015. And this was the first version of that, and it's a software as a service offering where people could pay for tiered service and be able to anchor data to public blockchains. So let me just describe a little bit about what this process looks like for anchoring. So over on the left, you can see you can take a hash of any piece of data. We usually use SHA-256, and you can submit that to Tierion. So we don't know anything about your data itself. We only get a hash. And we can't reverse that because the nature of hashes back to learn anything about your data. At certain points in time, Tierion will anchor that data to public blockchains. And we have kind of two blockchains that we deal with. One is an internal blockchain that we call the calendar. And this is something that we store in CockroachDB. And then a secondary blockchain that we write to is Bitcoin. Everybody knows about that one. And that one provides us with the most security guarantees because of the immutability of the Bitcoin blockchain. There's a proof of work that happens for every block that's written onto Bitcoin. And so in order to change the history of that blockchain, it would be extremely difficult, if not impossible, to do so. Once you submit that to us, we will go through a process of what we call aggregating that data. And we're essentially taking a bunch of Merkel trees, and we'll talk a little bit more about that in a moment. And we anchor to the blockchain, and then we give you back this Chainpoint proof. Chainpoint is, you can go to chainpoint.org and learn more about it. It's an open standard. It's typically in a JSON LD format, and it's essentially a recipe for a cryptographic proof. And we can anchor to other systems as well in the future. We're not limited to Bitcoin. And the interesting thing about our use of Merkel trees is that Merkel trees allows us to scale tremendously. We'll get into the details of the Merkel tree in a moment, but essentially we can take multiple levels of aggregation and anchor data at multiple levels, handling millions and millions of proofs per day. So this is easy for customers to work with because it's such a lightweight thing for them to take a SHA-256 hash of a piece of data and submit that up to our system. It's a simple HTTP call, and you come back a little bit later, and you will actually receive back your proof when it's ready. It does take a little bit of time to generate the proof. So let's talk a little bit about the Chainpoint Network. So I mentioned this is the chainpoint.org website. This is where you can learn about the actual proof format, which we have as an open standard. By the way, all of the software that Tierion operates is all open source. Our clients, our backend servers, the open standard is all open source. So let's talk a little bit about Merkel trees and why they're so powerful for us. This is a nice little demonstration for those who aren't familiar with a Merkel tree. You can imagine that up at the top of the the tree there, those are the leaf nodes. And a leaf node can accept an individual SHA-256 hash. So each one of those A, B, C, D, E, F represent a SHA-256 hash. And then what a Merkel tree does is it combines pairs of those hashes and hashes them again. And so A and B get hashed into AB, and C and D get hashed into CD, and so on down the tree. And you can see that in this demonstration, they're actually mixing colors. So if you were mixing colors, you end up with a different color as you move through the tree. But the interesting thing is that for every hash that's submitted into the Merkel tree, we can also generate a unique proof path for that specific hash. And out at the bottom, a Merkel tree root will come out, but we can prove that any one of those leaf node hashes exist in the final hash by using this proof path that lets you walk through the appropriate set of steps only relevant to your hash that get you to this final Merkel root. So this is a designified version of what a chain-point proof looks like, but it gives you some of the elements that are in our JSON LD proof. We have your original hash. We have a unique hash ID, which is a version 1 UUID with a timestamp embedded in it. This is a high accuracy NTP timestamp that we're attesting that you submitted this hash at a certain point in time. And then we have a series of operations, and you can think about this proof kind of like a recipe, where we have a series of operations where we are hashing data. It's all of those elements of that proof path in the Merkel tree that I discussed. And you can hash and hash and hash as you go through this thing, and at the end, you'll come out with a final value if you calculated out the entirety of this proof. And that final value is what you'll find anchored into a public blockchain. So we have two types of anchors that we typically include in a proof today. One is called a calendar anchor. I mentioned that's an internal lightweight blockchain that we maintain and share with our nodes in our network. And then we have another anchor which represents the proof path all the way up to the Merkel root of a Bitcoin block. So we have a lot of infrastructure involved in this process. The simple view of anchoring data this way is that, oh, you're just creating a Merkel tree, and then you take the Merkel root and you stick that up into Bitcoin. And yes, you could do that, but it's not able to achieve any kind of scale whatsoever, and you're going to spend an awful lot of money on anchoring to Bitcoin because the fees can be rather high sometimes. Back in January, it was as high as $30 to $40 per transaction to anchor onto Bitcoin, and we do that every hour. So we have a bunch of infrastructure in place. We are a Node.js shop. Everything gets packaged into Docker containers. We run that in Kubernetes. We glue all those services together with RabbitMQ. But all of the critical, mission-critical data for us is stored in CockroachDB. And some of the other components that are of interest there are the Bitcoin full nodes. That's what we use to send transactions out to the Bitcoin network. And then we also have Ethereum full nodes that we use as part of our incentivization scheme to incentivize operators to run nodes on our behalf. So let's talk a little bit about the very high level of our infrastructure. You can see here we've got an A, B, and a C, and these are what we refer to as core zones. And so Tierion operates 3 cores. These are running in the same region, but different availability zones of our cloud provider. And within each one of these zones is a whole suite of software services that are running. And they are all completely independent of each other. They don't cross-talk between these zones at all. And this is so that we have a very highly redundant environment that our nodes can talk to. And the database that I'm representing there, that's CockroachDB. And that's the only thing, with one exception, that's the main thing that is able to talk cross-zone. So it is the source of truth for all of the most important data in our system. And then these little boxes that we're representing here on the sides and the top, those are representing what we call nodes. And nodes are individual servers that are running out on the network. Currently, we have close to 7,000 independently operated servers that are not run by us, that are run by members of our community. And they are incentivized to do so using a cryptographic token, a cryptocurrency token that we created last summer. And if we drill down into one of these zones a little bit, you can see that, well, one point I would make here too is that when a client wants to submit a hash to us, they never actually talk directly to one of Tierion's servers. They talk to one of these nodes out on the network. That's the ring around our core that provides us the ability to scale. So if you think about these Merkel trees that we're creating, if one of these nodes can handle 1,000 hashes per second, and it does its own Merkel tree aggregation, creates its own Merkel root, and then once every 5 seconds submits that up to core. So the cores are only responsible for handling hashes from all of these nodes, these 7,000 nodes in the network. So we can get a tremendous economy of scale. This allows us to have users be able to create tens or hundreds of millions of hashes per day and let this core infrastructure handle all that. And these nodes are also running Node.js. They're in Docker containers, and they provide an HTTP API that any JavaScript client or HTTP client, and we have some other languages that we're going to support as well in the future. And if we drill down into one of these core zones, we can look a little bit about at what this infrastructure looks like. We have Cloudflare up front, which provides us with HTTP caching and acceleration. We have a second layer of caching, which is Varnish, that sits between Cloudflare and our Kubernetes infrastructure. Kubernetes exposes a load-balanced IP address for HTTP calls into our API service. And then also running in Kubernetes, we have about 20 other microservices that are doing all of the work of anchoring things to blockchains and various levels of aggregation that are happening throughout. As I mentioned, we also glue everything together with RabbitMQ. And then we have these stateful services like CockroachDB. In each of our zones, we run 3 CockroachDBs, so we run 9 total in our Cockroach cluster. And then I mentioned we had one exception where we do share some data between those 3 zones, and that's using something called HashiCorp's console. And we use this primarily for leadership election. So within our microservices, we often have a need to have one service be the leader amongst these zones. And if any of those zone services were to crash or the whole zone went away, then that leader would be chosen out of another zone. And I will try to do a very quick demo, but I need my mic stand back. Let's just run through the process of creating a hash and submitting that to the service. So we can do a SHA-256 sum of a file. I have that nice CRDB JPEG sitting on my desktop. And so that gives me a SHA-256 hash. And then I'm going to use our command line client, which is called chip for Chainpoint. And I can do chip submit and that hash. And now what's just happened is my CLI client has gone through a service discovery process and has found a core and then has asked that core for a list of healthy nodes that it can talk to today. And all of those 7,000 nodes that are out there, we audit every one of those every 30 minutes. We reach out to them via HTTP calls, and we issue cryptographic challenges to every one of them to prove that they are on time, they are serving the correct NTP time, and that they have a cryptographically provable copy of our entire calendar, which has been synchronized down to every one of those nodes, and some other aspects that we query for. So we've gone and submitted this now. I can do chip update all, and now I'm going to go and check whether my proof is ready for that particular hash. So this is the last one that came in, and I can tell because it's the one that is anchored to only to our calendar and not to calendar and BTC, Bitcoin. The reason for that is our calendar anchoring is very fast. It typically takes about 10 seconds, 10 to 15 seconds for that entire aggregation process to happen between the nodes and the core and writing that as a block into our calendar. And then you can retrieve that proof very quickly. Now that proof is strong in its cryptographic assurance that you submitted a piece of data at a certain point in time and in a certain state. But we also then, at the top of the hour, will submit that to Bitcoin as part of a transaction. And Bitcoin, we wait for 6 confirmations of that block. So that takes about 10 minutes for each confirmation. And that results in roughly 60 to 90 minutes until the Bitcoin proof is ready. But for every client that's submitting a hash, we recommend that you retrieve both versions of the proof. And then once you have that version of the proof, you are the custodian of that proof. So I can, you're doing a great job, by the way. So I can take a look at one of these. Whoops, did I just delete part of that? I think I did. So this first thing that I'm copying and pasting here, this is the UUID that I mentioned earlier. Every proof, every hash you submit to us gets assigned a unique UUID. And that serves as a handle to retrieve your proofs later. So I can show this proof, and I'll pipe that through JQ. And now we can see, here's this nice JSON LD formatted document. And this contains some metadata, including the original hash of your document. And we have a number of branches and these operations that are happening. And you'll see L, which stands for left, and op, which is operation, and another L, and so on. Each of these is just a left concatenation or a right concatenation. And so you're adding hashes together and rehashing them again, and you keep hashing and hashing and hashing until you go through this whole recipe. And then out the end of that comes a value, and that's what actually gets anchored into a blockchain. And for one of our Bitcoin proofs, you can see here we have an anchor point there, an anchor ID, which is a block height, and then we have a URI where you can go and retrieve that block. And for a Bitcoin proof, we will actually, here's just an example, that thing will calculate, that proof will calculate out to a Merkel root, which you can look at on any Bitcoin block explorer or your own copy of the Bitcoin blockchain, and you can verify that a Chainpoint proof is valid all the way up to a Bitcoin block without ever talking to Tierion. In fact, you can do all of that calculation locally using an open source piece of software that we provide and you can keep forever. And all that you would ever need is access to a copy of the Bitcoin blockchain, which should be hopefully around for quite a while. All right, so I'll jump out of that demo. Thank you very much. Okay, so let's talk a little bit more about Tierion and, yes, question?
If I want to store my hash, do I have to buy your I have to pay your token, right?
No, you don't. So the token economy that we're working on is between nodes and the core only. If you're a client and you want to submit an HTTP request or use our JavaScript client to submit a hash, you would actually talk directly to one of those nodes, and there is no cost for anybody to send hashes to those nodes, and you can send an unlimited amount. It's free.
Okay, so those nodes, so one of your miners, like the node that's actually storing the data, their hash, do they get paid? So they get paid by their tokens, right? So do they get paid by token when they started hash, or
no,
they get paid when they serve?
Actually, neither. So what happens is we do this, we want to incentivize node operators to run nodes so that we can have this large network which offers us these tremendous economies of scale and ability to handle large amounts of incoming hashes. So we want we want a healthy ecosystem of nodes out there in the world. Those nodes serve 2 primary purposes. One is they are the recipient of hashes from any client. And the second purpose that they serve was really 3 main purposes. Second purpose they serve is they are also the point of contact to receive back your proof from that node. So you come back 15 seconds or 90 minutes later and you ask that node for my proof, which you're going to keep. And then the third function that they serve is that every one of them keeps an entire copy of our Chainpoint calendar, which is in CockroachDB. We expose that through an HTTP API, and every one of these nodes, 24/7, has a real-time view, near real-time, of the exact state of that calendar. So what that allows them to do is they can also be a point of verification for a proof. So if you want to verify that a proof is valid, you can use our clients, and you can calculate the result of what's in your Chainpoint proof, and then you can submit that proof up to, you can query that calendar on any one of these 7,000 nodes and check, is the final value that I calculated in this proof, does it match what I expect it to see in the certain block height in our calendar? And if it does, that means that your proof is valid. So we want to incentivize these node operators to do that, and we do that using our TNT token, the Tierion Network token.
So when
And
do they get the token paid?
the way that they receive the token is by operating the node. I mentioned we do these health checks every 30 minutes.
Okay.
And so we maintain an audit history of healthy nodes, and we want to incentivize healthy nodes. So every 30 minutes, we pick a selection out of that list of healthy nodes that have been healthy for a period of time, and we reward them in TNT tokens.
Got it.
So that's their incentive. There's no per hash or per proof or any of that. It's just a mechanism by which we reward them on a relatively frequent basis.
Okay.
And it's random. That's correct.
How do the miners monetize the tokens?
How do they monetize the tokens?
Is it on a the public exchange? Your token?
Yeah, TNT is listed on a number of public exchanges. That's right.
Got it.
So you can keep it. You can. We require you to have a certain stake of those tokens in order to operate a node, so you have some skin in the game. But those tokens are yours, and you can do with them as you choose.
Okay, so what's the incentive for someone else to buy that token? I'm not paying by token to submit my hash, right? So why would someone buy it? So what's the demand for the token?
So at the moment, we're primarily using the token to incentivize this node ecosystem. We have plans, which we have not yet announced, to improve and enhance that ecosystem so that there's actually a bidirectional flow of tokens between node operators, and so they will actually pay into the network in order to, because we're providing a service at the core, which is expensive. We operate a lot of infrastructure, and we pay all of the Bitcoin and other anchoring costs, which can get into the hundreds of thousands of dollars a year just for the anchoring fees. So we're trying to build an ecosystem there using the token to allow that exchange.
Got it. Thank you.
Yep.
So I might be a little slow, and I just want to see if I've got this concept. Sure. So is an application of this is something like I own a trucking company, and I've got my truck filled with a whole bunch of stuff, and it's basically a list of parts in the truck, and I want to know at a point in time what was in that darn truck, you know, and because data changes over time, I take a snapshot of that basically the parts that are in that truck. I run it through your system, and I could take any part, and I know that it belongs to that lot. Is that like an application? It would be for like all sorts of warehousing and manufacturing and all of those things, even tracking grapes that come into a facility for freezing. So is that the kind of stuff that it's being used for?
Yes, and let me give a couple of examples of how people are using that today. So one example is we recently did a webinar with a company called Ultimus, and Ultimus is they provide business process management services. So they have a large coterie of clients that work with them, and they manage workflows of documents and data as they pass between different entities. And one of the things that they're looking at doing right now, and we did a live demo with them a couple of weeks ago talking about this, is that the management of one of those business process management units can specify that a document or some aspect of a workflow as it passes from one hand to another can be required to be Chainpoint proofed at that moment. So at any time as that data changes during its life cycle, you can quickly take a SHA-256 hash of that and submit that to us. And then you just schedule the retrieval of the proof, and you keep that proof alongside that hash. So as long as you can recreate that piece of data by rehash that original piece of data and arrive at the same hash that you submitted in the proof, you can now prove that that document existed at that point in time. A simple example is something like a contract. If you and I are making a contract, to sell something between each other, we're going to have a piece of paper or a document, electronic document that both of us are going to sign. And then we can take a snapshot, a SHA-256 hash of that signed document, and then submit that to our system. And that proves forevermore that if some judge asks us 2 years from now, how do I know that this is the right contract? How do I know it, isn't changed by 2 words or something like that? Because you can have this proof alongside it, which proves that I can rehash this document, arrive at the same SHA-256 hash that is in the proof, and I can prove that this proof works all the way up to a Bitcoin block, which existed 2 years ago and could not have been modified in the time since then.
That's a good explanation. Thanks a lot for that.
Sure.
Could you use Tierion for verifying databases, whether it's records or if you want to take a snapshot nightly or other uses within a database?
Yeah, so interesting working here with a database company. We might want to do a use case like that. Absolutely. So if you imagine if you had a table full of records and you wanted to snapshot the state of that entire table and all of its records, as long as you can deterministically order the records that are in there and recreate those at some later point in time, where you can say, okay, I snapshotted records 1,000 through 1,999, and they're ordered by their primary key. And I SHA-256 each one of those, and then Merkel tree that whole thing into a single Merkel root that would come out of the entire state of that database at that time, or those set of records. All I have to do then is submit that hash to Chainpoint, and I keep that Chainpoint proof. Now, when I keep that Chainpoint proof, the tricky part is the company has to know that this hash was associated with records number 1,000 to 1,999 in the database, and to be able to reselect those in order to rehash them so that you can prove that the hash hasn't changed over time. But that's a very lightweight process, and I mentioned that the nodes will do some aggregation. Customers can also do their own aggregation. You can build your own Merkel trees, and so really when you think about how Merkel trees work, you can have an unlimited number of items be represented at the pinnacle with a single hash. And it's really an infinite number of things that you can put together. Does that answer your question? Yeah.
While we're talking about applications,
Sorry.
I don't know if you'd rather take these kinds of questions now or later, but audit logging. So it's really important in like security and compliance kind of processes and things like that, especially on the business side. Are there any particularly any set of tools that are using this really neat technology in order to do to guarantee audit logs are actually correct?
I'm not aware of some for that particular use case, but it's one of the million use cases. Pretty much every time we talk to somebody about the business that they operate, we find ways that they could use a technology like this, because we feel it is really a way to add trust back into the internet in a way that you can anchor that a certain data existed at a certain time. That's a very fundamental thing in an age where it's very easy for a DBA to go in and change a record somewhere, right? And if you can have a mechanism that lets you see that that changed and to be able to prove that it changed, that's a powerful thing. One interesting use case that caught my attention some time back was a financial services provider who was doing kind of chat conversations with their clients about executing some form of trades, financial trades. And what they were doing is actually, and this is a proof of concept, but they were hashing every back and forth message between you and me and the entire conversation. So they could hash every individual, hello, how are you? Fine, thanks. Back and forth, hash each one of those, because it's such a lightweight thing to do. And then you can take all those hashes and string them together in the order that they occurred in the conversation, and you can put those in a Merkel tree, and you submit one root, and that one root represents not only every message that was sent back and forth, but the ordering of those messages as well. It's that kind of thing where we just see, not to be hyperbolic about it, but we see kind of unlimited uses of this. There's so many uses for something like this. Tierion loves CockroachDB. We're happy to be a featured customer. That was exciting to see that show up on, and we liked this cool blockchain artwork with Tierion at the end of it. That was kind of cool. Talked a little bit about this. Why did we choose CockroachDB? We looked at a number of different solutions. One of the interesting requirements that we had for these cores is that cores need to operate potentially across heterogeneous cloud environments. So we may partner with others who may offer cores of their own, and they would participate in that core network. So we couldn't have anything where we used a cloud provider specific database solution where there's any form of lock-in in those tools at all. The fact that we can use CockroachDB, publicly expose those nodes with the TLS security that it offers, and be able to run those across multiple zones in our case, or potentially across multiple clouds, was an absolutely critical requirement for us. And this is mission critical for us. This calendar that is sort of the beating heart of this whole system is absolutely critical that it be correct. And we need to build new blocks on that calendar and know that they are hashing the results of the previous block in the calendar, and there's no chance of having a fork in that chain. And we've really enjoyed the first-class support that CockroachDB has been providing us. We're an enterprise customer, and it's been fantastic in helping us where we have had some issues. They've helped us work through those issues, and that's really the definition of support, not the promises that companies make up front. It's living up to those goals, and it's really been a great experience working with Cockroach Labs on that. Some of the data that we're storing in Cockroach, we have this calendar, we have all of the nodes that get registered, all go in there. Every time we take in a hash and create a Merkel tree, and I mentioned there's this proof state that comes out of that lets you construct our proof eventually. That's a lot of data that has to exist for a short period of time. So we have kind of a delete-heavy workload, because we're constantly writing in. For every hash, we may write 5, 6 records for every hash that comes in. And then at some point later, after we construct a proof and give that back to the client, we don't need that data anymore. So we have to delete it and prune it away. And that's critical to us. Some of the performance stats, I mentioned we run a 9-node cluster. We've run our own testing where we've done 4,000 plus operations per second on that cluster. We have also done load testing where we involve thousands of our nodes simultaneously in submitting hashes through core. And we believe we can sustain pretty easily 100 million plus hashes a day through that network of nodes. We have now pretty good latency times. We're typically about 1 millisecond for 50th percentile latency, and that's at a relatively low query level of 100 queries per second. The delete-heavy workloads, as I mentioned, this is important to us, and was a little bit of a gotcha where we got support involved. Something called tombstones, and I won't go too in-depth on that, but deleting data leaves some aspect of that data around for a period of time, which slowed some things down for us. And we needed to change that garbage collection interval from 25 hours down to 1 hour so that we could flush that old data away very quickly. Otherwise, our database could get overwhelmed under a scenario where we have many thousands of nodes submitting to us under sustained load. And we've seen nice stability in production, and every release seems to bring some performance enhancements, which is always the right direction. And I can announce today that we are running CockroachDB 2.0 in production. So we were on the release candidate a couple of days ago, and then you guys threw me well, not too surprising, but the 2.0 release came out today, and I upgraded it earlier today across our 9-node cluster. So that's it. We are, as always, hiring, and thank you very much. Any more questions?